Hi and Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Amir Irfan bin Muhammad Shukri. Today I will present question 2, 5 and 6. First is question 2. A 600 megawatt steam power plant which is cooled by a nearby river has a thermal efficiency of 0.35%. Determine the rate of heat transfer to the river water in megawatt. So the given is 600 megawatt and efficiency 0.35%. With given value, we can use the formula QH equal W net out over thermal efficiency. Then we put the value in formula 600 over 0.35 and we get the answer is 1714.3 megawatt. After that, the rate of heat transfer to the river water is determined from the first law relation for a heat engine. So we can use the formula QL equal QH minus W net out. So we put the value in formula 1714.3 minus 600 and we get the final answer is 1114.3 megawatt. Question 5. The refrigerator in a kitchen receives electrical input power of 130 watt to drive the system and it rejects 300 watt to the kitchen air. Find the rate of the energy taken out of the cool space in watt and the COP of the refrigerator. So assume a steady state, so there is no storage of energy. And the information provided is W equal 130 watt and the heat rejected is QH equal 300 watt. So the energy equation give is QL equal QH minus W. So we put the value in formula 300 minus 130. So we get the answer is 170 watt. This is also the rate of energy transfer into the cool space from the warmer kitchen due to heat transfer and heat exchange of cool air inside with warm air when you open the door. From the definition of the coefficient of performance is COP of a refrigerator can be expressed as QL over W. So we put the value in formula 170 over 130. So we get the final answer is 1.31. Question 6. A household refrigerator with COP of 1.6 remove heat from refrigerated space at a rate of 62 kJ per minute. So determine the electric power consumed by the refrigerator in kilowatt and the rate of heat transfer to the kitchen in kilojoule per minute. So for the solution is the COP and the refrigeration rate of a refrigerator are given. So the power consumption and the rate of heat rejection are to be determined. So we assume the refrigerator operates steadily. For question A, using the definition of the coefficient of performance, the power input to the refrigerator is determined to be W net in equal QL over COP refrigerator. So we put the value in formula 62 kJ per minute over 1.6. So we get the answer is 38.75 kJ per minute. But the question want in kilowatt. So we change the value in kilowatt and we get the final answer is 0.646 kilowatt. For question B, the heat transfer rate to the kitchen air is determined from the energy balance. So the formula is QH equal QL plus W net in. So we put the value in formula 62 kilojoule per minute plus 38.75 kilojoule per minute, and we get the answer 100.75 kilojoule per minute. That's all from me. Thank you.
Assalamualaikum. My name is Mohsen Amili bin Rosdi. Today I'm going to present the question 7, 8 and 9. We start with number 7. An air conditioner produces a 2 kilowatt cooling effect while rejecting 2.6 kilowatt of heat. What is its COP? From the given information, we get the cooling effect is QL equal to 2 kilowatt and the amount of heat rejected Q.H is 2.6 kilowatt. By applying the first law of thermodynamics for the system, W.net equal to Q.H minus Q.L. So we put in the value and subtract, we get 0.6 kilowatt. Next, we use the coefficient of performance of refrigerator is defined as a desired effect to the work input. So we can use COPR equal to Q.L over W.net. So we'll put in the value 2 over 0.6 kilowatt. COPR we get 3.3. Number 8. An air conditioner removes heat steadily from a house at the rate of 500 kilojoule per minute while drawing electric power at the rate of 6 kilowatt. From the question, we are given a value of QL equal to 500 kilojoule per minute and W net in 6 kilowatt. Number 8A, the COP of this air conditioner. We can use the equation of COPR equal to Q.L over W net in. So we put in the 500 kilojoule per minute over 6 kilowatt time 1 kilowatt over 6 kilojoule per minute, and then we get 1.39 for the COPR. Question 8B. The rate of heat discharged to the outside air in the kilojoule per minute. So the rate of the heat discharged to the outside air is determined from the energy balance. So we can use equation Q.H equal to Q.L plus W.net in. From the value given, we can substitute the formula with 500 kilojoule per minute plus 6 times 60 kilojoule per minute, and we get 860 kilojoule per minute as a final answer. Next, for number 9, a residential heat pump has a coefficient of performance of 2.4. How much heating effect in megajoule per hour will result when 2.1 kilowatt is supplied to this heat pump? So from the question, we get in value of COP heat pump 2.4 and work W.net in 2.1 kilowatt. By applying the definition of heat pump coefficient of performance to this heat pump, give is Q.H equal to COP heat pump times W.net in. So we can substitute the value in question. So we get 2.4 times 2.1 kilowatt. Since the answer in megajoule per hour, we have to change to the hour. So we time 3600 over 1 hour time 0.001 mega over 1 kilo. So we get the final answer is 18.14 megajoule per hour.
Assalamualaikum warahmatullahi wabarakatuh. I am Fatiha, matrix number B0920103744. Today I would like to explain the question number 10 and 11. A heat pump with a COP of 1.5 supplies energy to a house at a rate of 75000 kilojoule per hour. Determine the electric power drawn by the heat pump in kilowatt. So, from the question, we know that value of COP is 1.5 and the value 75000 kilojoule per hour. Then the question asks the electric power drawn by the heat pump in kilowatt. So, from the equation, COP equal QH over W in. So we can get the value for electric power drawn by the heat in kilowatt. Next, substitution value of COP and QH into the equation to get the value W in. The value that we get is 13.89 kilowatt. The next is the rate of heat removal from the outsider air in megajoule per hour. So the equation is QH minus W in equal QL. Okay, then QL equal to 0.833 kilojoule per second minus 13.89 kilojoule per second. The question want heat removal in unit megajoule per hour. So we convert 6.94 kilojoule per second by multiply with 6.94 kilojoule per second multiply 6 second over minute multiply with 60 minute per hour. So the answer is 25.0 megajoule per hour. A heat engine is operating on a Carnot cycle and has a thermal efficiency of 75%. The waste heat from this engine is rejected to a nearby lake at 13 degrees Celsius at a rate of 800 kilojoule per minute. Determine the power output of engine in kilowatt. So QH equal 800 kilojoule per minute. So we convert to kilojoule per second. Then the answer is 13.33 kilojoule per second. Question A asks the power output of the engine in kilowatt. So we use the thermal efficiency equal network output or over total heat input. Thermal efficiency is 0.75 equal W net. Then W net plus 13.33 kilojoule per second. So W net equal 0.75 per 0.25 multiply with 13.33 kilojoule per second. The answer is 40 kilowatt. Last but not least, the temperature of the source in degrees Celsius. So the formula thermal efficiency is 1 minus temperature low over temperature high. Then we substitute the thermal efficiency, which is the value is 0.75, and we substitute on the value of temperature lower is 286 Kelvin. Then the final answer is 871 degrees Celsius. That's all. Thank you.
Hi, my name is Harsan Asmail and I will be presenting for the question 12 for tutorial 4 for dynamics. The question 12 is a heat pump operates on a current heat pump cycle with a COP of 7.9. It keeps a space at 24 Celsius by consuming 4.25 kilowatts of power. Determine a question the temperature of reservoir in Celsius which from the heat is observed. From this equation, we must extract the data on the text. The data we get from the text is for the first temperature is 24 Celsius. We must convert it into Kelvin by plus 273 we equal to 997 Kelvin. And for this OP we get 7.9 and the power input is 4.25 kilowatts. For the first question, we use formula COP heat pump equal to TH over TH minus TL. And then from the equation, we move the COP heat pump into over TH over COP HP. And we input the data from the text we equal to TL equal to 297 minus 297 divided by 7.9. We equal to TL equal 297 minus 37.594. And for the next step, we will finish the step by TL equal to 259.406 Kelvin. But the question it must be in Celsius. Then we minus this 273 we equal to negative 13.594 Celsius. And for the next question, B, the heating load provided by the heat pump in kilowatt. For this question, we will use a COP heat pump equal to heating effect divided by power input. We must transfer the power input into COP heat pump. We max it COP heat pump multiplied by power in, and for the next step we will get heating effect equal to heat pump multiplied by power in, and then we insert the data we get from the text. We equal to heating effect equal to 7.9 multiplied by 4.25, and we will get the data 33.575 kilowatts. For question 13, current refrigerator operates in a room in which temperature is 25 Celsius. The refrigerator consumes 500 watts of power when operating and has a COP of 3.5. Determine A, the rate of heat removal from the refrigerated space in kilojoule per minute, and B, the temperature of refrigerated space in Celsius. First, we must extract all the data from the text. That with the data we will get is temperature for the first temperature is 25 Celsius. We must convert it to Kelvin by plus it 273 we equal to 298 Kelvin. And for the 500 we equal it to the power input. And for the COP is 33.5. For the first question A, the rate of heat removal from the refrigerated space in kilojoule per minute. We will use a COP refrigerant equal to QL over W net. And then we input the data from the text we get from before. We equal to 3.5 equal to QL over 500. And 500 we will move to 3.5 we equal 1750 watts for the QL. And then the question which S is in kilojoule per minute, and we convert it into 105 kilojoule per minute. And for the next question B, the temperature of refrigerated space in Celsius. We will use a formula of COP refrigerant equal to TL over TH minus TL. And we insert the data we get from the text. There is 3.5 equal to TL over 298 minus TL. And then we move the 298 minus TL to the other side. We multiply by 3.5. and then we equal to 1043 minus 3.5 TL equal to TL, and then we move the negative 3.5 TL into the other side, we equal to 4.5 TL, and for the last step we divide the 4.5 divide by 1043, and then we will get 231.78 Kelvin. But the question is it asking in Celsius. And then we minus it, 231.78 minus 273 Kelvin, we equal to TL negative 41.22 Celsius.